Okay, we've run our Monte Carlo simulation and we produce some output. In this particular case, it's the newsboy again, and we got an output there of the demand and profit for 1,000 trials. And I added a column here just to help me visualize. I coded it using an if statement. If the value here is greater than 4, if H4 is greater than 4, print out positive, and that's just using the word we want with the double quotation marks before and after it, else print out negative. And so that gives me this particular value. And then I use the conditional formatting to color it green if it said positive and red if it said negative. So that's how I got that column. But how do we use this to make some decisions? And that's the whole point. Can generate a bunch of statistics using the descriptive statistics tool in the data analysis if you want, or just plugging in some individual values here. I've got the mean and standard deviation of the profit, the max and the min, and then assuming that this was the output is a distribution that is suitably modeled by a t-distribution, I found the confidence interval using the confidence.t, which requires the alpha, 95% will be 0.05, and then the standard deviation there of 91.18, and then we've got the n, which was 1,000, and that gives me the half width of the confidence interval, and then adding and subtracting that gives us the upper and lower limits of the confidence interval. So it would say if this distribution is suitably modeled by a t-distribution, then we could be 95% confident that our profit would be between 154 and 143. But, and that's a big but, is this distribution something that's suitable to be modeled by the t or the normal distribution? Well, the way to answer that question is to create a histogram and take a look. Now, there's more complex methods you can use to actually see if a distribution is technically normal or technically t-distribution, but we're just going to look at the histograms and then make a decision. And I'm going to zoom over here. I've built the histograms using the technique that we've seen, and this profit distribution is obviously not normal, not a t-distribution. So we have to be very careful using a standard distribution to model this. And that's interesting. If you look at the distribution of the profit versus the distribution of our random variable, the demand, if you remember, you stay in this particular last model, the demand was modeled using a uniform distribution. And so this printout there looks fairly uniform. So that tells us that the Monte Carlo simulation using that part. But it just goes to show that your output variable may or may not parallel the distribution of one of your input variables. And in particular, if you've got multiple random variables, say a uniform and a discrete and a normal and a triangular, you've got all those input random variable distributions, you really have to look at your output variable that you're concerned with to understand how to interpret the results. Since this is not a typical distribution, we're going to have to just use the empirical way of coming up with some answers here. And what I did, I asked the questions, what is the probability that the profit will be greater than $230 in this case? And to find out, we just use the count if function. And in our range for profit here, in our H column, from H4 to H1003, that's our 1,000 output values, we run a test, and if we're testing against a value, we need to enclose it with the double quotation marks. And here I wanted the test to see if whatever was in this profit cell is greater than $230. I wanted to count it, and if it was not greater than 230s, to not count it. And then to get the percent, we divide that by 1,000. And that came out to be 36.3%, or the COUNTIF brought back 363 places or outputs where the profit was greater than 230. So we'd have a 36% chance of making more than $230. If you wanted to find a range, in this case, someone said, what is the probability of the profit being between $200 and $230? And one way to do that is to use the COUNTIF again. And what I did there, I've got two COUNTIF statements. I wanted to get the total count greater than $200 profit using the same method there, and then subtract from that the count of profits greater than 230. So that would get us the interval in between, and of course just divide that by 1,000. Now I use the sum function here for that, but you really wouldn't need to do that if you're just using these two COUNTIFs. If you had multiple COUNTIFs, then the sum function would help you do that. And then finally, if you wanted to do an analysis of a column like I've added here, where I've got a text output, and I want to know the probability that I'm getting a negative profit, you could do it, of course, with profit less than 0. But here I just wanted to get a count of the number of times that negative showed up. And we use our COUNTIF function again. Same, well, this time it's the I column range where I put those text outputs. And we count the number of times that negative shows up. All you do is put in the double quotations again, the value, the word that you want to return. And you need to make sure that you're spelling it the same way here that you spelled it over here. And I divided that by 1,000 and got 7% chance of getting a loss with this particular model.